Perfect.
Let me just get orders from our true masters. Daniel, Leonardo, can I start? Okay. Okay, so we have the possibility to start, and welcome everyone. So it's going to be the first of this series of talks that we have every year on telemedicine and e-health. It's associated with the works of our Master in Medical Informatics here at the University of Porto. Every year we try to have a mixture of guests coming here visiting us from industry, academia, health institutions, national, international. And so, it's once again a great pleasure to start with a bang. And so today we have with us Nuaman Tazi. Nuaman Tazi comes from, if you're a computer scientist, you're probably more into these things, but it's one of the most exciting companies, I would say, at the moment. Hugging Face. We were together in a summer school in Paris. And it was very exciting, and Nuaman tells me it's even more exciting now. So our expectations are through the roof. So some quick logistics. So this part is open. We're transmitting online and recording. You can still ask questions, no problem whatsoever. If you're not shy, I'll just give you the microphone and keep this interactive. I asked our guest this, and it's perfectly fine. But after around 45 minutes and near the end, we'll apologize to our online viewers, stop, and then we have Nuaman just for us, and we can discuss. So Nuaman, thank you so much.
Thank you so much
for visiting us, and we're very excited, and the floor is yours.
Thank you. So yeah, thank you, Professor Miguel. Thank you so much for having me. It's a pleasure to visit the University of Porto. So yeah, once when Professor Miguel invited me at first, I was very excited to talk about this specific topic. Well, AI, since it's the domain I work in, but healthcare as well, because recently I have a very delicate experience. I actually lost my father recently to lung cancer, and that made me realize just how important it is. Even with all the technology, like I had ChatGPT in my pocket and stuff, but we couldn't, we just couldn't do anything with all the advancements we have without the expertise of doctors and of you, of course. So I'm very happy to be here, and please reach out to me if I can help with anything in this field. I am very happy to be here and very happy to help even after this talk. So yeah, and let's get this started. And please also, I'm gonna try to make this as interactive as possible. So feel free to leave any comment if you experience something like this before. I know there are nurses here, there are doctors here, computer science people as well. So I trying to make it not as not technical. Like I left some technical parts to the end, and I would really like to get your opinions about what you're gonna see in this talk. So yeah, we're living at exciting times. AI started the revolution since 2020, and especially with the release of ChatGPT 2022, November, I think. A lot of people who never heard of AI started hearing about it, started using it. Some people started even asking it about what could happen in the future. A lot of misconceptions going there. And it's especially interesting for healthcare because I think you all probably saw Google's medical AI chatbot is already being tested in hospitals. GPT-4 can save doctors' time, etc. So all of this is exciting, and when you hear, for example, that a healthcare org with over 100 clinics uses GPT-4 to write medical records, and the newest version of ChatGPT passed the US medical licensing exam with flying colors and diagnosed a 1 in 100,000 condition in seconds. So how much of this is hype and how much of this is real? So I don't know, I hope that you can see the numbers. Otherwise, I'm gonna just highlight what's important. So I took some of these results of This is the State of AI by McKinsey of 2024, of course. And this one showcases how respondents are much more likely now than in 2023 to say that they are using generative AI. Basically now, and especially you can see in healthcare, I always highlight the healthcare stuff in red. This is what's important for this talk. So you can see that in 2023, and I don't know if I can point. Oh, okay. Okay, perfect. So in 2023, you can see that only like 17, like all the blue open shade, 17, 10, 6, like regularly use outside of work generative AI, whereas the others have tried at least once or never used it, compared to 2024, where more people are getting confident in saying that I use generative AI in my work. This is not like something scary or something that I should not be using. Here again, organizations are pursuing a mix of off-the-shelf generative AI, or are they building their own models? And if I understand here, most of you are trying to develop your own models. You're not just trying to consume what's already in there. This is debatable. I'd like to get your opinion at the end. If we should use, for example, ChatGPT as it is, or if we should customize it to our own needs. And here we can see that 47% develop their own model versus 53. So it's almost half and half. And here we can see like the investments in AI in the different fields. So for example, in this is, okay, so at the right is analytical AI technology, at the left is generative AI. So you can see that investments of analytical AI technology for healthcare, it's much more than generative AI. And you can also notice that the investment in generative AI in healthcare is one of the least ones, because it's the one where we definitely don't want any hallucinations, any errors, because that's a death or life matter. This picture just shows the increase of the investment in AI. We can see that in the latest years it's getting more and more. Everyone is interested in AI. And here we can see what's the percentages of AI companies, what's like the highest, most invested in. So since 1990, health is invested this much. And last year, health was the second most invested in like startups and all for AI. Another cool thing to keep track of is how much FDA is licensing of medical devices. Because if FDA licenses a medical AI, means that they trust it enough to implement it in clinics. And we can see that, can we full screen this? We can see that there is a rising trend. This was before the end of 2023, so it's still rising. And in red, we can see that the number of medical AI devices licensed for children. So it's also rising. And what's the domain that these AI medical devices are used to? We can see that radiology. Is the first one where FDA is licensing devices in. So we can see, for example, that in 2022, I think this button doesn't work. Or maybe because I keep pressing it for a long time. It's maybe mine. Okay, it's my mistake, I'm sorry. We can see that most of the devices licensed are used for radiology, whereas the other domains, I don't know which domains you are working in, but the other domains are still heavily lacking behind. One thing that could probably explain this is FDA doesn't, it's not like there is less research, but it's just that people who work on these domains don't take the extra step of making sure that these solutions are robust and we can trust the solution in what they give. And then, of course, some drama, some recent drama. So this is Greg Brockman. So for those who don't know, this is the current president of OpenAI who owns ChatGPT. And this was in November 17, so a couple of weeks ago. He said that human doctors, so this is a small-scale study on accuracy of diagnosing illnesses. So human doctors can diagnose 74% of these cases. Using ChatGPT, it jumps to 76%. ChatGPT alone successfully diagnosed 90% of these cases. So I'm gonna let you for a couple of minutes take your own interpretation. And of course, his takeaway is vast potential for AI to help with diagnosis, but need better human-AI teamwork. This is the article in Google. It's taken from the New York Times. AI chatbots defeated doctors at diagnosis illnesses. And the second result is AI chatbots did not defeat doctors. The main point at the study was to determine whether access to an LLM would help doctors diagnose more effectively. And of course, if we open the article and we skim it quickly, we're gonna find results of the study should not be interpreted to indicate that LLMs should be used for diagnosis autonomously without physician oversight. And it goes to say that basically the context of the study was done with the help of physician. They gave the context necessary for the LLM to answer. If it was just the LLM, you gave it a bunch of data, he could hallucinate very easily. So, and that's another very important thing that we can think about. So for a physician, when they have a patient, what is the information needed to make a correct diagnosis? Is it just the text that goes out of the patient? Is it his whole physical thing? So what you see, what you hear. So you're gonna do a lot of checks before you diagnose. It's not like, because for an LLM, it's only the text, like just past history maybe, and just text, but it doesn't have like the entire context of what you're seeing in front of you. And of course, we also had this part of like a similar tweet. This was in 2017 by Andrew Ng. So he said that should radiologists be worried about their jobs, we can now diagnose pneumonia from chest x-rays better than radiologists. And this one's in 2017. But did radiologists disappear now? Of course not. So like this isn't the first time that people are getting overconfident. AI is going to replace doctors and stuff. We had this before, but nothing changes. What we should aim for, though, is a better collaboration between doctors and between AI. And this is what most of the labs work for. For example, Google DeepMind recently. This is Together AI, another startup. So they released Evo, a machine learning model capable of decoding and designing DNA, RNA, and protein sequences. This is a couple of weeks ago. And Google DeepMind, of course, the goats in this area. So they had a protein, because for these tools, we're gonna see this later, it's not only what they learned, they can only use tools. For example, they can search the web, find information, and then give it to you. So it's a great tool to summarize what's on the internet, give it to you, and you're the expert at the end. So you are the one who is going to decide. So why all this hype? What's happening? So there is what we call foundation models. Foundation models are like very big models that were pre-trained on a lot of data. And I'm gonna give you a concrete example. For example, ChatGPT. ChatGPT that almost everyone uses, has been trained on the entirety of the internet. So imagine all the websites, all the books, everything that's written on the internet, ChatGPT has already seen at least once, right? And he can remember a lot of these things. He can make connections between things, right? So, and this ChatGPT is an example of what we call a foundation model, which means that any other or some other people can use such models, fine-tune them or train them more on their data, and this model can be specific to this data. So we get a general model, and then we make it specific to a small task. And this can be done in healthcare as well. For example, these people have trained CLMBR. This is a model for FEMR. It's just one specialty in healthcare. And we can see that it gives better performance than CountLR. CountLR was just one model, task specific. It was only, for example, trained to, I don't know, understand ECG, or it was only trained to do segmentation of some chest x-rays or something. So if you take a foundation model, a model that has seen a lot of other things, and you specialize it on one single task, it becomes better than a model that was only trained to do one thing. So this is a very important lesson. A lot of you I talked with earlier, we're working on something. So always check if there is a foundation model out there, open source, that you can use and that you can fine-tune on your use case. What's the other benefit is they need less labeled data. And this is a great thing to hear, especially some of you here who spend hours annotating data, trying to find the data. If you find a foundation model, you probably only need look here, number of labels. You only need 100. So the red ones are the foundation model. And you can see how they start. Like even with 100 labeled data, they are already the best. They are already better than the alternatives. And then the more you feed it labels, the more they become the best. So this is a very cool thing, especially in healthcare, where there is a privacy issues and stuff. If you use a foundation model, fine-tune it, you're gonna get better results. And of course, and this is something that not a lot of people in academics think about, why are you doing your research? To hopefully, sometimes a startup or an industry takes your research and apply it in a clinic. So there's gonna be someone who deploys your model. And so if I give them a model for ECG, someone gives them a model for chest x-rays, it's gonna be tons of models out there, very small ones specific to a lot of tasks. Who is going to deploy this? Where, how? So it's gonna take a lot of money and cost. This is in the future, of course. For smart clinics, they're gonna have a lot of devices, each with their models, and someone needs to coordinate, or probably the doctor needs to coordinate. Whereas if we had, for example, let's say one smart robot, like the ones from Tesla, that Elon Musk showed. We have one smart robot who has smart sensors. He understands how to diagnose ECG, a lot of stuff. Then that would be very useful. And besides the robot part, if we have just one, for example, like ChatGPT, but who is expert in all of healthcare. Like he knows how to segment chest x-rays, ECG, any other modality you think of, that would be very easy for the clinic to deploy, and like researchers can convince industry people better to deploy them. And this is also a big, this is an achievement. All of this are happening. Like, I'm glad that I found that some researchers in healthcare that think this way. So someone thought of using LLMs to facilitate medical consent. Because let's say someone in some foreign place needs to do a surgical operation. So this is the original surgical consent. Try to read this. My condition and the above procedure have been described to me, alternative treatment, blah, 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 blah. Whereas the simplified surgical consent is like, you have the right to know about your surgery and other treatments. This form is your agreement in writing. Like, they could have made that much simpler. Of course, some of you are going to say there are some details. What about providing both examples? Like, and people can see both, or forms this way. Because, if I'm gonna read this, I probably won't. And some people have difficulty reading things this long. So this is a very interesting form of using LLMs to do a very important thing, like consents. I think you're gonna find this in a lot of places in healthcare. So dream bigger, like we have now all these amazing tools, models that can understand what's in images, what's in videos, what's in audio. So a lot of things. So think of how can we use these new tools that we have. These are all new tools to make people's life easier. And this is also very interesting. Most existing tasks like NER is the task of labeling some words in a sentence. And readmissions risk, this is a classical challenge to predict if a patient needs to be discharged from the hospital or not. These tasks are already extensively studied. So we need new tasks, like how can we make people's life easier? Especially now that LLMs can dialogue with people, like we can converse with them, we can understand emotions, we can see them, like voice mode by OpenAI. Soon we're gonna have like open source examples of that. So there's a lot to work on. Oops. And this is the part that I just talked about, multimodal. Did anyone see MedPalm before? No? MedPalm is a model by Google, and M stands for multimodal, because the previous generations only had text. And you're gonna notice this a lot. Like a lot of models, they start with text, like ChatGPT. Now ChatGPT can understand a picture, and it can understand a voice, if you send a voice. So a lot of models, and open source is always catching up. So if ChatGPT is closed, you can't use it, you're gonna find an open source models that do the same thing. I should probably accelerate a little bit. So, and in the video, this is an example of a easy and cool interaction that a patient can have. So for the past few weeks, I have noticed multiple stuff. He's gonna send a picture. The model say, have you recently been exposed to any new plant stuff? No, I don't think so, etc. So this is a conversation that he could have with a doctor, but the doctor would charge him a lot, right? I mean, imagine if you're a doctor and you're gonna spend your time doing this to a lot of people. Doctors don't do this for free, right? So imagine if, at least for a first consultation, of course, help people get these types of feedbacks. And of course, these models need to be validated by experts and stuff before being deployed, or these models can be in the hands of the doctors. So the doctors can like talk, get the feedback of the AI, just like to validate their ideas or stuff. I think that's a very useful use case. And you can see here example of the modalities. So there is dermatology, mammography, genomics, radiograph, radiology report, medical knowledge, pathology. So MedPalm can take any of those and can do a lot of tasks. So this is what we're trying to achieve right now, multimodality. So some of you can say, okay, but does this really exist? Like, are people working on this? And I've took this survey of LLMs for healthcare, 2023. So there is a lot of research being made currently into how to integrate LLMs, large language models, into healthcare. Most of them like date from 2022 to now. And you can see the parameter size, you can see some features, like some of them are multimodal, some of them have RAGs, and most of them are on GitHub. And having the coded GitHub means they are open source. Open source means that you can play with this yourself. You can fine tune it more on your use case. You can understand how it works, etc. And this is to get an idea on what's the cost of training these models. These models are what I called before foundation models. So these labs have trained these models from scratch. They gave it a lot of data so that not everyone needs to do the same. So for me, if I just want to fine tune it on my 100 labeled examples, I'm gonna take one of the previous models. fine-tune it with 100 labeled data that I have, and I'm gonna better results than if I wanna train from scratch, collect a lot of data, and do the rest. So you can see here the GPU time. Some were trained only for 2 hours, and some were trained for days. Same for the training data. We're getting more and more of training data, but don't get fooled with this. Like a lot of these things are very small, like 4,000. I think for the LLMs, most LLMs are using Mimic 4 and PubMed. These are, I think, the most famous data sets. So even if you find a lot of models, like a lot of models are similar because they were trained on the same data. So this is a big call for anyone who knows a doctor, or if you are a doctor yourself, if you manage to organize your data, if it's possible to either publicly share it or share it privately with some researchers to develop your work, it will be very useful. Like this is the time where data is money, basically, and data is like usefulness for everyone. If you manage to like get data, organize it in some way or another, that will be very useful. If you can't, and this is an issue, an understandable issue in healthcare, a lot of data has privacy issue. We just cannot share it because it's like people's private data. We can try of generating data, so synthetic data. And this is an example of how we can generate synthetic health data for breast cancer patients. And this is an LLM, for example, ChatGPT, that generated a fake data for a patient. So everything you can see here is fake, and it looks like the real thing. So this is a smart way of using LLMs that can now that have seen the entire internet, and they can imagine a lot of stories. And this data is fine to share, right? Because it's just imaginary. It's no one's. But still, the question remains: how much real data is necessary, and what are the privacy risks? Because the more real data you have, the better the results will be. And we can't, of course, share data because there is a privacy risk. But we also need to share as much real data to include as many rare diseases as possible. Because if we don't have enough data from the real cases we have, we're not going to cover these rare cases in our models. And if the foundation model don't have access to the rare diseases, it's very hard. Like all the fine-tunes, it's going to be less quality than if the foundation model included it. And of course, Hugging Face have, like if you are a computer scientist or if you want to work on this, Hugging Face have done something similar, but just for pre-training, so not for healthcare, how to create large-scale synthetic data for pre-training. And the thing with Hugging Face is they give you everything, right? So they give you the code, the example of data you can train with, they explain what you're doing. So yeah, thanks to these people. And then we also have another tool in Hugging Face that lets you, like, I played with it before the talk. I gave it an example of a data that I want to generate. Like I said, medical data set, lung cancer. And it started giving me like fake or synthetic data of what I want. So you can play with it. This is just to get an idea of what's the synthetic data you're gonna use. And you can try different LLMs and see the results. You can also like control the columns you want in here. Here I just let it to give me the columns. And you can also do the same thing for images. So these are, for example, for dermatology. So when generating images, you can either do quite some techniques like in painting. So you're gonna give just the borders and AI is going to generate the center. And the thing with generative AI is that it's imaginative. So it's going to change the form in a lot of ways So it's very similar to what you can get with real data. So you can do in painting, out painting, and a lot of mixes. And then Dream Booth, you can just give it like an example of an image and a text, and it's gonna generate to you what you want. So this is like creative ideas, what you can do with generative AI to get more data. And this is the result of what you do when you add synthetic data. So there is this question, if I include synthetic data, am I gonna get better results or worse results? And this proves that, so this is 16 real example, and here I'm gonna add synthetic data. So if I start only with 16 real example, this is what I get. So the more synthetic data I add, the better the model gets. But we can also notice something else. If I start with 64 real data, it's better than if I start with 16. So if I start with 16 real image, and even if I add synthetic images, I'm just gonna reach, for example, 30%. Whereas if I start only with 64 real data, I already start with 30%, and then enhancing it with synthetic data gives me even more performance. So the lesson of this is the more real data you can give the model, the better it will be. And you can always add synthetic data to gain more performances. Now that closes the explanation of the hype. Now we're gonna see what's happening a little bit in the LLMs domain. Do you have any questions about what we saw so far? All good? So there is a common belief that now we need to train bigger and bigger models. But recently we found that more people are training smaller models. And Hugging Face, for example, recently they trained small LM2. And you can see here the size of small LM2. It's this size. And it's good. It's as good as GPT-2. So for example, small LM2, this one has like 200 million parameter. It's as good as this one. Or for example, probably some of you are familiar with Llama, the latest Llama, which is Llama 3.2. So this one is like 3 billion parameter. We trained a smaller model, which is 1.7 billion parameter, and it's as good as this one. So this means, and what's the difference between this one and this one? Why is small LM2 better than Llama 3? It's more data. We just gave it more data, trained it for a longer time. So the code to train and the architecture are the same. Now the difference between LLMs, it's just two things. The number of data, the size of the data sets you have, and very shortly, the recipe, what we call now recipe. It's like now they're cooking new models. Basically, let's say you have a lot of data sources, one for books, one for scientific articles, one for memes somewhere in the internet. So the question is, how much percentage should I take from each source and give it to the last, like what we call the decay phase? It's the last stage of training. And that last stage of training determines a lot the evaluation scores you get at the end. So this is specific to LLM pre-training. You probably won't need this. You're just gonna try to fine-tune on healthcare. But in the LLM industry, and to make new LLMs, they have these challenges. So for you, specifically, if you wanna train or use these LLMs, what do you need? So this is for computer scientists mostly. So for the training models, there is SFT and RLHF. SFT is supervised fine-tuning, and RLHF is using reinforcement learning. For this, there is a library called TRL by Hugging Face. So I'm just gonna cite the libraries because once you open it, everything is explained with an example. I mean, it's very clean. You just have to go there and you're gonna understand what you're doing. Plus they give you example of codes, of data sets you can use, like everything. And for usage, there is a couple of techniques that we're gonna see later. For this, I recommend LangChain. Parameter and communication efficient methods, adapter, so there are these ones. So for parameter efficient, I recommend PEFT, and I talked before with some of you about the lack of cluster. I mean, everyone is lacking compute and data centers so far. For this, for example, let's say I have a very big model, like it has 7 billion parameters or something, and I only have 1 GPU. What I can do is I can quantize it, like reduce the size of the model so that it can fit on my device. For this, I'm gonna use PEFT, this library. PEFT is parameter efficient fine-tuning, and it has all these methods. It explains what's the difference and so on. And this one is for big training. This is coming soon, and this is, by the way, what I'm working on. So yeah, I didn't actually introduce what I'm working on. So I'm working on a library called Nanotron. It's the library that enables large trainings. So for example, it's the library that I made and I helped building. It's the one that was used to build Small LM2 and StarCoder 2 before it, and LLMs in general. And of course, it's open source, so feel free to check it out. It's called Nanotron. And we're gonna make a blog soon to explain how can we, like for labs that have big clusters, if they wanna pre-train their own LLMs, how they can do it. So I said that, so there are a couple of techniques currently that are being used, and I'm just gonna give you a general idea. So how can these people reach these very good performances? There is ICL, which is in-context learning. So for example, here, I'm gonna give him example number 1, example number 2, and this is, I'm gonna give it to ChatGPT in the prompt. This is basically gonna help you understand how to give better prompts to ChatGPT so that you can get better answers. So instead of just giving him question and I'm expecting an answer, instead I'm gonna give him an example 1. So this is the case, this is what I'm expecting. Example 2, this is the case, this is what I'm expecting. And then I'm gonna give him another question, and the answer should be similar to what I gave before. This is what we call in-context learning or few-shot prompting, which means I'm giving some examples to the models to understand what I'm asking. The second technique is chain of thought. And this is a very fun one, because usually when we think of LLMs, for example, ChatGPT, and when we give it like a very hard puzzle, like no matter how hard it is, ChatGPT gives you an answer in like milliseconds. Like once you click enter, it starts answering without thinking. But for us humans, if I give you a very complicated challenge, you're gonna take some time to think, like read everything. Probably you're gonna start breaking it, thinking like step by step, and then give me an answer. So funny enough, researchers found out that we should do the same technique for these LLMs to get better results. So this is what I mean. So for example, typical prompting, I'm gonna give a question. So this is the case of a 50-year-old female patient which has 2 sicknesses. So what kind of tests should be done? Answer, and imagine you gave this to ChatGPT, he's gonna give you a direct answer. Now let's use chain of thought. So I'm gonna give the same question, but at the end I'm gonna do, please assess symptoms and patient history and consider possible causes. So just by adding that in the prompt, the model is going to be, it's like if it's thinking, it's like if the model is thinking, he's gonna say, the patient is 50 years old with a medical history of type 2. She reports sudden severe abdominal pain and vomiting. I actually don't know what's the answer. So, and then we can even push it further. So, okay. So these are 2 inputs to get the answer. So step 1, please assess symptoms and consider possible causes. The model gives you this. And then I'm gonna tell the model, according to the above analysis, further analyze symptom relations with potential diseases, and finally recommend further tests. And then he's gonna be like, answer potential diseases. 1, this is the first answer. 2, this is the thing. So I don't know if I explained well enough or not, but basically it's like when I asked him this first question, it's like I'm breaking the problem, which was very complicated. This one is very complicated to answer. And the chatbot, when he's generating this, it's like he's thinking, right? It's like he's taking more time, repeat what he took in the prompt, like he's gonna start thinking, and then he gives you an answer at the end. And they do this for reasoning tasks specifically because they need reflection. The third thing, so now we've seen few-shot prompting, we've seen chain of thought, now it's tool use. Now a lot of LLMs, for example, ChatGPT, I think, if you give him a math equation, you're gonna see ask in Wolfram Alpha, for example, because ChatGPT is going to use a calculator to answer your question. This is what we mean by tool use. Because LLMs usually, when you ask them something, they're gonna answer you from what they learn already, what they know. It's like even if you cut off internet, you don't get, it's just the model, he's gonna start answering. But sometimes we need them. For example, if you ask him, what's the weather today? The model like trained on very old data. Like he doesn't have the information of the weather today. So we're gonna teach him, okay, here is the API for the weather. When I ask you what's the weather, you're gonna ask Google, for example, what is the weather, get the answer, and then you're gonna report it. So it's a very nice way so that LLMs stop hallucinating. They don't answer us from what they know. And you can imagine, for example, in healthcare, let's say you have ChatGPT, you asked him about like a patient you just had today. So the LLM is going to look in the database for your patients. He's gonna look for the relevant information from the patient folder, and then he's gonna give you the answer. So this is another type of tool, and we can give all types of tools. And of course, Hugging Face also have a blog for that if you wanna learn how to do it. And the code is very simple. So you just define the tool you want, and you can implement it as well. And then the final, and I think everyone talks about this recently in the AI field, LLM agents. So what do we mean by agents? I'm gonna get here an example of code because it's very simple. So if I say, please write code for a task, this is the answer, this is an LLM. We can imagine this is ChatGPT. And I'm gonna ask him, please write code for something. So he's gonna answer me, do task. And then let's say I found a bug. So I'm gonna tell him there's a bug on line 5, fix it by stuff. And he's gonna fix it and give me a better answer. And then it failed unit 3, try changing, etc. So what are we doing here? So I'm interacting with ChatGPT. I'm giving him a task. He gives me an answer. I tell him to fix it. He fixes it and gives me another answer, etc. So it's like I'm giving him feedbacks. Every time I give him feedback, and he gives me a better answer. So people tried this. How about we use ChatGPT here, and we use another ChatGPT that would give the first ChatGPT feedbacks. So let's say this is the LLM. He's gonna do task. And then I have another agent, which is also an LLM. So this is all automatic. He's gonna try running the code, and he's gonna report back the bugs. And then the first one is gonna fix it and give it to the other one. The other one is gonna say what the bugs. So here, the human is out of the loop. Like we don't even need a human anymore. As long as this guy, this LLM, can run the code, he can basically do the same thing that I do, because what did I do before? I just try to run the code, and I tell ChatGPT it doesn't work. And so this is why agents are cool, because these two LLMs, they can both be ChatGPT. So it's the same LLM. It's like I'm gonna tell him you have schizophrenia. Basically, you have two personalities. One is going to write code, the other is going to test it. And it's like, it's what we call self-reflect. So the model, when he gives an answer, he thinks, okay, did what I say correct or no? And then he tries to fix it. And that works a lot. And some people pushed it even further. Why not have a village of LLMs. So this is one big LLM, and we tell him, okay, you're gonna play the role of a startup, of a lot of people coding. So you have some people testing, some people documenting, some people coding. All of them are the same LLM, but he's just playing multiple roles. Everyone, like every person tries to do the task and reports back. And this apparently, so single agent in some task, like it gets a score, like 66%. But when you use this technique, multi-agent, it gives better performance. And this is like we're teaching these LLMs to think. So now the big question is, how can we make ChatGPT think like humans? And other people took it even further. This is just 2 days ago, by the way, this article. I don't know if you're familiar with Minecraft, a game. So basically, they took hundreds of LLMs. Everyone has a different personality, and they left them in Minecraft. Basically, they could command the characters and so what they can do. Apparently, they found, since these LLMs learned from humans, right? So it's like we're reinventing humanity. Apparently, they started making jobs. They invented jobs, they made friends, and they invented their own religion, apparently. Because, of course, they learned from the internet. So that's what humans did. So this is very interesting, and we can have a lot of sociology studies about this. And yeah, so many cool things. Basically, we're living a revolution right now. Yeah, everything is very exciting. And I think I should speed up a little. Oh, actually, there is only 10 minutes. Okay, so maybe I'm just gonna, because I think just 2 things. So yeah. So what could go wrong? Basically, GPT 3.5 sometimes can give very bad, so it's not like magical, so it can give bad answers. So we need to evaluate these models correctly. And there is a lot of evaluation tasks, and here is where we need expertise the most, because physicians are helping making these LLMs, these things we don't really understand how they work, because basically ChatGPT, you're asked to give you something and he gives you an answer from the internet. So sometimes he can give you anything, and we're just trying to like make him listen to us. Basically, that's what researchers are trying to do. And Hugging Face for this thing, they did open medical LLM leaderboard. So if like anyone in the medical domain have a new medical LLM, you can find it in this leaderboard. There is a lot of scores on a lot of benchmarks. And there's also a blog, and it explains what are these benchmarks. So this is a good read if you wanna read about these things. And this is, let's test our understanding. So recently there's a new Gemini models, and we can see that on this benchmark mid-QA, it's even better. It has 91, better than GPT-4. Cool. Medical benchmarking. So apparently it's even multimodal. So there is a lot of interesting tasks that were done by expert physicians. It could be related to your domain. So it's probably worth checking if what you're working on already is in these evaluation benchmarks. And if so, what are the good models that are doing this? Because this is a multimodal model. So it takes text, it takes images, and it takes audio. So probably what you work on is in there. And so how did he get, like Gemini, how did they get this performance? Let's check here. We're going to find COT, chain of thought, which is what we saw earlier. Basically, where they are trying to make Gemini think using the techniques we saw earlier. And basically here, for example, so you have instruction, test question, search. He's going to think, confident. If he's confident, he's going to give the answer. No, he's going to do generate search queries to resolve these conflicts. So basically, he has conflicts. He's going to search in the internet, which is tool use, and he's going to web search. So he's going to find something supporting A, additional context, refuting B, and he's going to correct himself. So we're trying to make these models think before giving an answer. And a lot of people prefer Gemini over experts. And last two things, explainability, because some people are working on this. So saliency maps aren't helpful all the time. In this case, saliency map tells you what the model looks at, but if it's skin cancer, it's always the same. So what they did instead, which is very clever, they use generative AI, like they have a reference image. They're gonna ask a model to create two pictures. One picture which is a case of benign, and one picture which is a case of malignant for that specific case. And they do that on a lot of scenarios, and they check what are the factors that influence the predictor. So for example, if this model, for example, I don't know what's the name, they find out that hair influences the prediction of this model. For example, if this model finds hair, he thinks that the cancer is malignant, basically, but it shouldn't be. So this is a way to explain the predictions of these models by testing it with a reference image and generating a positive and a negative case. And the last thing is bias. So they try to ask ChatGPT some questions, some racist questions. And so the white ones are the racist answers. For example, what is the genetic basis of race? And the red ones are the not biased answers. And even with like the very good models we have now, some racist beliefs still are there. And apparently in this research, they say that these beliefs come from the trainees that are in the hospitals. So even like some race beliefs are, for example, I don't remember what was the example. I think, yeah, it's fine. I forgot the example. Cool. I think I'm gonna, yeah, I went overboard. Sorry.
The rest of the next topic.
Yeah, or maybe I can share with you the slides.
Sure. Okay, thank you very much. Thank you, Noaman. Thank you so much. Excellent talk. So maybe we'll stop the online part now. Please, Leonardo. Thanks. And okay, so I don't